Alrighty, so we are going to get started. Welcome all. Thank you all so much for coming. I'm Haley. I'm a graduate student at West Virginia University working with Maura McLaughlin on Pulsar stuff, but I also do a lot of science communication. And so today I'm going to be talking to you about Astrobites and how you guys can get your research published on Astrobites. So if you haven't heard of it, I will do a little intro as to what it is. Okay, can you guys see that? Awesome. So Astrobites is the AstroPH Reader's Digest, which basically means that we take summaries of recent scientific papers or classics and write them, just kind of break them down to a level that most people can understand. Anybody who has taken an astronomy or physics class before. It's run under the American Astronomical Society, and we usually, most of our posts are recent papers written by a team of graduate students, but you can also, there are also more opportunities to publish undergraduate research. If you just go to astrobites.org, you'll find this little bar. So we also publish undergrad. So you see we have daily paper summaries, classics, but this little tab is undergrad research, and it appears just like this. And so these are written by undergraduates. So there are two different ways that undergraduates can publish in Astrobites. Undergraduates don't tend to have a lot of ways that they can get their work out. Sometimes you'll be on a big research project and you'll be on a paper, but sometimes you won't. So this is a really good way to get research out. I'm going to be talking about a couple of different posts today. The first one is just a basic undergrad research post. It involves submission of a paragraph or two about your research, and the research doesn't even have to be published or even completed. You can still be in the process of doing this. And again, you can write the basic undergrad research post, or you can write a longer post about your experience, which I'll talk about later. And I'll give you instructions and samples and such on how to write these. You can also write a guest post. That's something I won't really talk about today, but if you do want to get practice summarizing scientific papers, you can also just write an Astrobite itself. Let me know if you have questions on that, and I can give you some resources on that. So for each undergraduate post, any undergraduate post, experience post, guest post, you will be paired with an Astrobites author like myself who will help you edit your post. And the post will be put up on our social media, our Twitter, our Facebook, and so your research will get out there, and it looks great on a resume or a CV. It's great to put, you were published on Astrobites and people can see your work. So today we'll focus on how to write a general undergraduate research post. So the general format, so it can be published or unpublished work. If it's something that you've put time and effort into and want to, share it with the world, we really want to see it. It doesn't matter where you are in your project, you can submit these. So the guideline, it says to submit fewer than 200 words. It's not very strict. If you go like 250, it's not a big deal. A write-up using a form online that I'll show you. The target audience is one familiar with astrophysics, but not necessarily your subfield. And so try to write clearly and avoid jargon. This is something that I know a lot of people struggle with, myself included. And so this is where the editor will help you out with this if you have trouble. You can also include a short bio, which I will just talk about first. So you should provide a clear 1 or 2 sentence biography describing where and when you did your research and where you are currently. Feel free to include a fun fact. Here's an example bio. Blaze is a rising senior studying physics at Gettysburg University. So just kind of where you are, what stage you are. This research was conducted as part of an astrophysics REU at West Virginia under the supervision of Dr. Maura McLaughlin. So you want to say, where you did it, who was your supervisor, and you can also include some fun facts. So for instance, in his spare time, Blaze likes to play frisbee golf, stargaze, and hunt for black widow spiders. Blaze is an undergraduate in my REU group, so that's why we're laughing. You can also include a photo about yourself. That's totally optional, and it can just be bare bones, or you can kind of talk a little bit more about your career aspirations or kind of whatever you want to include. So here's the super general structure. So of these posts, you first have an introduction or some background. You might have a sentence or maybe even a couple words about this, or a paragraph, depending on how much context you need for your work. you have some kind of research question or problem, and you'll see that each of these elements can be phrased a little bit differently. Methods that you use, maybe it's programs, maybe it's, observations. Your results, the significance of the results. So, why does this matter, big picture? And maybe some future work if this has, projects that'll spring off of it. And you can put if you're going to publish it or present it, that's totally optional. You can also include that in the bio, like this work will be presented at the AAS meeting. So here's a very, very basic example. So again, I have the elements kind of up here. So this is the example that's actually on our website. All of these are on our website, but this is the submission page. So the first sentence is, can we detect exomoons or moons around exoplanets? Boom, research question. To answer this question, I simulated the light curves or the light as a function of time. We would see it with the Kepler telescope if a planet with a moon passed in front of the star. So it's kind of the methods there. I varied stars, planets, and moons' physical properties like masses and radii. And so that's, again, how they did their work. I found that Kepler can detect large moons around small planets and small stars. Results. This result is surprising because previous studies indicate that Kepler cannot detect moons at all. Boom, significance. We plan to further explore this model to calculate how many exomoons Kepler should have detected over the past 5 years. Future work. This work will be presented in January at the American Astronomical Society meeting. So very basic structure. I think this is one that I actually used to make this checklist, but again, you'll see as we go through a couple more that you can have kind of various kind of plays on these, and you can do them a little bit differently. So the next one that we'll look at is, I tried to pick like pulsar gravitational wave ones. So this was by Ava Stockman, who is I think she's still an undergrad at Bellevue. So the blue here are going to be hyperlinks. So if you've ever read Astrobites, then you'll notice that we do a lot of hyperlinking. So if you click on gravitational waves, then you're going to come to a site that explains gravitational waves if you want to, to explore them a little bit more. And so you don't have to put these. I don't think the submission actually allows you to, but these are kind of a key part of Astrobites that your editor will help you with. So gravitational waves are ripples in the fabric of space-time generated by the acceleration of very large masses, for example, the merging of two black holes. That gives an example. The European Space Agency and NASA-funded Laser Interferometer Space Antenna, LISA, aims to detect new gravitational wave sources when it launches in the 2030s, opening the door for new discoveries in gravitational wave astronomy. So that's some background. LISA can detect gravitational waves at a wide range of frequencies, and this prevents data analysis challenges because many gravitational wave signatures are significantly below the detector noise. So boom, there's your problem. It presents issues, or it presents challenges because these signals are below the detector noise. So that kind of sets this up. The first LISA data challenge simulates LISA data by injecting gravitational wave signals into an idealized instrument noise model. The goal of the challenge is to retrieve gravitational wave information. So that's more kind of background. Ava presented the problem and then gave a little bit more background again, which is totally fine. The LISA data challenge, extreme mass ratio in spirals, contains a single simulated EMRI signal injected into instrument noise. The orbit of an EMRI is highly eccentric and complex and lasts for years before the merger, making for a complicated waveform. EMRI gravitational wave signals are multiple orders of magnitude lower than the detector noise and many other gravitational wave sources detected by LISA, making advances in data analysis strategies imperative for a successful EMRI detection. So kind of, again, a little bit more setting up the research question. By using the mock LDC master code, the noiseless EMRI data were successfully manipulated and plotted. So that's what they did. We calculated the signal to noise ratio and were able to recover the signal. We are currently working on a method to compare the simulated EMRI signals with a range of parameters to the LDC EMRI injection. So what they did, a little bit of future work. This project, as well as future LISA data challenges, will allow us to advance techniques for filtering noisy data, allowing the EMRI signal to be extracted from raw signal originally detected by LISA. So future work, they don't have, if they're going to publish it, that's totally fine. And then you can include a figure, but you don't have to. So this one, you can reference it in the text, which we'll see in an example, but this one just kind of illustrates their point. So they have a caption just telling all about the plot. It illustrates the MRI signal in orange. Make sure that when you do these, you explain the axes, explain the colors. And on the left, signal is plotted separately with different scales as highlighted in red. And on the right, they're on the same graph. As you can see, it's imperative to be able to filter the signal out since it's buried beyond recognition. So you want to illustrate the plots, kind of say what it shows and kind of why it's important. And then the last sentence will be, this is why I included it because it's really important. So that's the first one. We're going to look at a slightly different one, just so you can see kind of how these are they're all very similar. So this one is called Pointing the Green Bank Telescope by Ellie White, who is an undergrad. At least when she did this, she was an undergrad. So the Green Bank Telescope is an engineering marvel. Weighing at 17 million pounds with a 100-meter by 110-meter dish, it's the largest fully steerable telescope on the planet. So kind of setting the scene, kind of showing, how big the telescope is and kind of amazing you at first. One of the challenges for large ground-based telescopes like the GBT is achieving pointing accuracy that's good enough for observing at the high end of the telescope's 0.1 to 116 gigahertz range. So that's kind of setting it up. It's not specifically, we're investigating this. It's just kind of setting it up. As the frequency at which the telescope is observing increases, the beam size or pixel size gets smaller, meaning the pointing accuracy must be very high within just a few arc seconds for the GBT. The pointing performance of the GBT is degraded by factors such as the telescope's flexure due to gravity. When the telescope tilts to different elevations, it sags due to Earth's gravitational pull, which causes the pointing direction to change slightly. You can see that this kind of required a little bit of background, a little bit more background than the other one. Similarly, thermal expansion and contraction can cause deflections to the telescope's line of sight, and as can tilt and bumpiness in the azimuthal track, which is the circular track the telescope rotates on with its 16 wheels. So you can use hyperlinks to explain things, or you can, maybe in this case, you didn't have to have the hyperlink, or, hyperlinks can take the place of something like this, of something like the parentheses and explaining it, or you can have both. Again, it's totally up to you. As well as small misalignments and offset errors within the structure of the GBT itself. The GBT's pointing model corrects for these effects by including terms for structural misalignments, as well as terms incorporating meteorology data from the GBT structure temperature sensors and from logs of measurements of the track surface. And then this kind of gets to, so you do get the research question in here, but it's kind of buried, but it's really put in context. And so this is the second paragraph is kind of where everything starts, the methods and such. So in our project, we found that when the pointing model is applied with no calibrations, the blind nighttime pointing error RMS, which is the root mean squared, which is a statistical measurement obtained by taking the square root of the average squared value of the data points, was a mere 9 arc seconds, which is about 5/1000th the diameter of the full moon. This is something that is really good with science communication, just telling the public about science. When you have something like a measurement like 9 arc seconds, it's good to put it in some context that some people will kind of understand. I mean, it's really hard to think of 5/1000th the diameter of the full moon, but they just know that it's much smaller than the full moon. So putting that in context is always good. When calibrations are applied, the RMS pointing error is a fraction of this. Observers will see pointing accuracy on the order of 2 to 3 arc seconds, though further analysis is needed to determine a more exact value. So that's kind of a little bit of future work. Despite the GBT's asymmetrical design, which makes it more challenging to correct for pointing errors, our results show that the telescope achieves excellent blind performance pointing. So you can see that there's a little bit of extra work here. So maybe some future work, like further analysis, is needed. But overall, this project is kind of wrapped up nicely. And it's just, we did this, we found this, period. Whereas the last one that we saw has a lot more future analysis. So this one didn't have any plots associated with it. So Ellie chose to include a picture of the Green Bank telescope, which is totally fine. If you really don't want to include a picture, you can include anything. Just make sure that you have the image credits. So just if you talk about galaxies, maybe you can include some kind of picture of a galaxy. That's cool. It's totally up to you, and you don't have to have one of these. So we're going to look at just one more, just so you can see kind of the varieties. This one is about exploring the circumgalactic medium of quasars, a search for nearby interacting galaxies. So they say that one way of studying galaxy evolution is to look at why quasars are more luminous when there is cool gas around them or in the circumgalactic medium. I would probably put a hyperlink there, but I didn't edit this one. So that's just kind of setting things up. The CGM is the gas outside of the disk of a galaxy and within its virial radius. So you can see that this person doesn't explain what a virial radius is, but if you're very curious, you can go and ask. So I got a question. So these are all examples of texts that are supposed to be 200 words long. I didn't actually count on this one, but if they're like 200 to 300, it's not really a big deal. Definitely feel free to ask questions in the chat if you have them. I am monitoring it. Yeah, so 200, basically the size of an abstract is the goal, but they might get a little bit longer with editing. So we suspect that what is driving the luminosity in the quasars is that nearby galaxies are interacting with the quasar by either dynamically disturbing the quasar CGM or supplying their own CGM gas to feed the quasar. So boom, there's your research question. Here's what we were trying to look at. Here's the problem that we were trying to solve. So this is kind of our hypothesis. In order to answer this question, we observed 64 quasar fields with the Hubble Space Telescope in order to identify galaxies near each quasar that could reveal evidence of an interaction. Each field has multiple galaxies and 2 quasars. One background quasar is just used as a flashlight to probe gas from the foreground quasar, which is how we measure the galaxy distances to the nearby galaxies. From this sample, we observed 19 fields with the Magellan LDSS3 to determine the redshift and nebular emission line properties of the nearby galaxies, such as the O2, O3, H alpha, and H beta lines. We then used nebular emission lines as a way to trace enhanced star formation from the potential interaction. So that's kind of saying all that they did. If you took observations, make sure you say, what telescope you used, what kind of observations, did you use radio, infrared, and such. In my case, the field of this long SCSS number, I found 7 galaxies within the redshift range of the quasar. So Z equals 0.7, see figure 1. So you can include the figure. So we saw these a couple ways. So you can include the figure and reference it in the text. It can just be a pretty picture, or you can kind of use it to kind of sum up everything and just not reference it in the text like Ava did. This is one of the quasar fields selected that has cool gas with Mg2 absorption detected, where we might expect to find evidence of a merger. Using O2, we can estimate their star formation rates, and they have a couple of references in here that you could probably hyperlink these as well, as a function of distance to the quasar. We were not able to conclude that this is a relationship between the galaxy distance from the quasar and their star formation rates from our case study, and it's likely that we'll need full spectroscopic sample to gain more leverage in answering our questions, such as, is this evidence of an interaction, and why is this more luminous? The project doesn't have to be a success. If it isn't, if you can't find anything, that's fine. Just put, what other things would be needed to understand this. They talk about figure 1, just making sure that they address the X and the Y axes. So we plotted galaxy star formation rate. I don't know if SGF is, I would probably spell that out, as a function of distance to the QSO in the field. There appears to be no evidence for an enhanced star formation, which could be indicative of immersion or interaction. The one galaxy within the virial radius with low star formation rate could point to potential interaction that occurred a long time ago. So with the captions, especially plots, you're going to want to make sure that people understand, what the plot is, and that they don't have to go back to the text. It can kind of stand on its own. So those are 3 examples. Does anybody have questions about any of those examples besides about the word count? Different editors do it different ways. Some stick to the 200, some go a little bit over, but there's not a very strict word limit. Any questions? Can't see any hands. Okay. So those are a couple examples. So just a couple tips. I would read a few undergrad posts on the Astrobites website. That's a good way to get familiar with the format, because Astrobites kind of has a very specific format. Include hyperlinks with more information. I don't think you can do that in the submission box, so actually don't worry about that. You don't have to include a figure. If it adds to your story, include it. You can include a graph you didn't make, but again, make sure you have image credits. So there's a lot of variability that these can take, and basically just an abstract for a conference will do. If you have one of those ready, you can just submit it. If it needs to be fixed a little bit, the Astrobites editor will help. So the submission, you go to this website. I can send you guys a link to the slides. This will be sent to our editorial team. Again, there's just the editorial team is just a group of astronomy grad students. And so every editor, everybody that I've worked with is really nice and really helpful and has a lot of really good feedback. And your post should be published within a few months. We have a lot of posts that will be published, so it might take a bit. But if you just go to this website, and you can actually see the submission. So you got a little bit of information. You have your example and just name, institution, email that we can just use to get to you. Short bio, 1 or 2 sentences. It can be 3, doesn't really matter. Your title, abstract, figure caption if you want, doesn't matter. And then just make sure you're not a robot. Okay, so you can also write about your experience. So we had a lot of regular undergrad posts. We don't have so many of these, so we would really like to include more. So this can include anything from how you found a research opportunity to conducting research, overcoming challenges, learning a new skill. If you're not quite sure what to write about, here's a giant list that's actually on the website that I'll link to the post where this is. So you can talk about, how you found your REU. And so that'll be really useful for other students, or how it, what it was like working at a different institution, or, answer things like, did you work with other graduate students? Did you attend group meetings? What was your experience like? Was it part of a bigger program? Was there anything you and your fellow undergrads like to do? Did you guys go do things on the weekends? Did you find astronomy to be a lot more computational than you thought? Just talk about it. Did you give any presentations? And just in general, just include anything that you want about your experience. Here's an example. This one's really good. I don't think we have very many, so again, I would suggest writing one because they're really fun. You can write both. You can write as many as you want. So this person is a 4th-year undergrad and did a summer here. I like this. They stepped off the plane into Boston Logan International this September and eagerly exchanged a drizzly English summer for a beautiful New English autumn. And they just talk about their experience with research and such. First day, walking into my office, clutching a calculator, pen, notebook, mug, sat opposite my Unity computer. Talked about things that they learned. Talk about a name for the future to think of more descriptive file names. I often do that. It'd be like script 1, script 2. That's kind of relatable. Talk about the things that they used. And I like this end paragraph where they say that science is about a bunch of dots on the screen that hold so much information to the well-trained eye. A few wiggles here and there will make all the difference between a breakthrough and a null result. So that's a lot of astronomy, is just kind of staring at pictures that most people would look at like blobs. So that was kind of fun. Maybe that time, yeah. Okay, so they get kind of do a little bit of creative writing in here, but that's totally fine. This can be anything you want. When you submit something to Astrobites, everything is going to be accepted. If you email us with an undergrad post, we're not going to say we can't publish this. Maybe you'll have to do a revision or 2, but that's it. And so it'll hopefully be a fairly quick process, but everything gets accepted and you will have your stuff published. It might take a little bit of time, but it'll happen. So to submit a post, you're just going to want to send, an email to this submissions that go straight to an Astrograd student, and hopefully you'll hear within a little while with the usual guest post instructions. So that's here. If you just go to the website, it's right up here. I think the aim should be 800 to 1,000 words. It can be anything. This also goes for regular guest posts. And so your proposal can only be a few sentences. Hi, I'm Blaze, and I want to write about my experience with my REU this summer. That's it. So just very, very simple. And then they'll say, great, send us a draft. So that's it. It's very simple. And again, you'll be paired with an editor who will help you. Usually in Google Docs is what we like to use. Don't worry about the formatting. We will take care of everything. I thought I had an example. Yeah. No, I don't have an example. But just for example, I'll go to an undergrad post. That's what it was. Okay. So this is what it's going to look like at the end. We have this little header here that talks about the series. Everything is labeled UR, which is undergrad research. Picture if you want one. You don't have to have one. Your university, your bio, and then just some paragraphs, maybe a figure. It'll look all nice in WordPress. And again, you'll have an editor. So yeah, these are all just Astro grad students. You might be paired with me. I do a lot of editing of posts, but this is general structure. So does anybody have any questions? Feel free to unmute yourself, put it in the chat. It's totally up to you. I can put my email in the chat as well and a link to these slides if you guys have any questions. So at this point, I was just going to take this as working time. So if people want to work on them, I have my own RAU kids here. Yeah, thank you for coming. So if you guys want to hang out, I will stay on Zoom. And if you want to write up your own, that's totally fine. And if you want to just ask questions like, how should I phrase this? Or, you know, can you give me more examples and such? I can do that. I think I see a question in the chat. If two people worked essentially on the same research project, can we submit together? Yes, I believe we have done that. Yeah, so absolutely. We'll put both your names on it. You can put 2 bios. I don't think there should be a problem with that. Let me just put a link to these slides really quick in the chat. Fine. Okay, all these tabs. Okay. Yeah, you guys are free to email me. I will probably respond within 2 seconds because I'm really quick with emails. And if I don't respond right away, please ping me because sometimes I just forget. So here is the link to the, it's a link to the slides. My email's here. And there's the Astrobites website. So yeah, you guys are free to get started. If people want to stay on Zoom, awesome. If you guys want to leave, totally fine. So I think that I am going to stop sharing at this point, unless anybody wants me to, and I'm going to stop the recording.